We're doing domain, range, and period of the trig functions. Didn't label it. You look at this, you have to realize it starts at the origin and goes like that. You have to be able to recognize that that is the graph of sine. That quiz will be next week, where you guys are going to have to graph all 6 and give domain, range, and period for all 6. What is the domain? How far to the left does this graph go? All the way. How far to the right does it go? All the way. Does it stop anywhere in the middle? Sure doesn't. So the domain, negative infinity to infinity. All real numbers. What is the range of this graph? How far down does the graph go? Just to -1. How far up does it go? To +1. It includes both. So we bracket -1, +1, bracket. -1 to 1, including both endpoints. And the period. We have to remember that our definition for period is the distance on the x-axis we must travel before the graph starts repeating itself, is how we defined period yesterday. If we look at this, if we choose to start here, we travel along the graph this far. At that point, it would start repeating. So our definition from yesterday, what is the distance along the x-axis before it starts repeating? And that is, in fact, 2 pi. This one is hopefully, obviously, the graph of cosine. The nice part here, domain, range, and period for cosine matches up the exact same to sine. Same exact thing. This is the graph of y equals tangent of x, the domain, all real numbers, except you have to write the sequence. You have to choose some vertical asymptote to start with. We can start there at pi over 2, so it's except pi over 2 plus k pi, where k is an integer. The range goes all the way down, goes all the way up, never stops anywhere in the middle, so the range is all real numbers, and the period is pi. Then we have this one. If we graph the corresponding function, it's going to be like this. So that is the graph of sine. So this graph is y equals 1 over sine of x, which is cosecant of x. The domain, you have to pick one of the vertical asymptotes, like this one. So we say the domain, all real numbers, except 0 plus k pi, which is just k pi, where k is an integer. Our range, negative infinity to -1, or 1 to infinity, and our period, 2 pi. How far do we travel on the x-axis before it starts repeating? 2 pi. So here in number 5, we look at this. What we have to do is remember yesterday I pointed out, running on the assumption that you recognize that this is either the graph of secant or cosecant, and you're trying to determine which one. This, hopefully we can tell, corresponds to whatever graph is going to look something like this. And following this graph, we can see right here that this purple graph is cosine, which means that what we have is y equals 1 over cosine of x, which is secant of x. This you do have to know for the quiz tomorrow, right? The graph is next week, but to be able to evaluate the trig functions tomorrow, you have to be aware of this relationship, that secant is 1 over cosine. So then the other part is that we have to worry about the asymptotes that are present. We have all of these asymptotes, which means that when we talk about the domain, we're going to be able to say, looking at this graph, it goes all the way to the left, all the way to the right. Does it stop anywhere in the middle? Yes, it stops here, and 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 here. And it's going to keep stopping at regular intervals. So our domain is going to have to be given as negative infinity to infinity, except. And then we have to write a sequence of numbers. That sequence of numbers is going to be either arithmetic or geometric. So we have an arithmetic sequence because we're adding the same thing each time. Plus pi, plus pi, plus pi, plus pi, plus pi. So we are all real numbers except, and if we remember our formula for an arithmetic sequence, it is the first term, and the nice part is for the first term you can pick any of these vertical asymptotes. I will choose to start here. So it's all real numbers except pi over 2 plus k pi, where k is an integer. So this notation right here, I can write it a little bit bigger to make it clear. K is an integer. Capital Z represents the set of integers. For the range here, goes all the way down, goes all the way up. Does it stop anywhere in the middle? Sure does. It stops here. So my range, negative infinity to negative 1, including negative 1, or positive 1, including the positive 1, to infinity. So we can be anything negative infinity all the way up to negative 1, and negative 1 is the highest we'll get on that section. Then we jump up to positive 1, and we go from positive 1 up as far as we'd like. So negative infinity to negative 1, or 1 to infinity. Lastly for this one, what is my period? How far must I travel on the x-axis before the graph starts to repeat? If I choose to start here, I would have to travel to here before the graph starts repeating, right? Start at the bottom of this parabola, go up, then we travel along this, travel here, so I'm at the bottom of the parabola, I'm going to start going up. So this is the distance I go before I start repeating, so the period is 2 pi. Number 6, which graph is this? It is cotangent. Y equals cotangent of x, where my vertical asymptotes are here, 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 and here. So again, we're going to have to do the domain involving a sequence where we say all real numbers except who can give me the formula for the sequence of numbers that are not included in the domain. So we say except pi plus k pi, where what do we have to know specifically about k? It's an integer. K must be an integer. Now I will say that that is equivalent, pi plus k pi where k is an integer is equivalent to just saying k pi where k is an integer. Because you can choose whichever asymptote you would like to start with. Right? At first somebody had chosen pi. It's equivalent to choosing 0. You could choose, if you wanted to be a little bit of a smartass on the quiz, you could say the domain is negative infinity to infinity, except for 1,673,476 pi plus k pi where k is an integer. The range in this one is very easy. The graph goes all the way down, goes all the way up, never stops anywhere in the middle. Range is all real numbers. What is the period? How far must I travel on the x-axis before the graph begins to repeat? That's that distance in this graph, which is pi, because I'm going to go jump, and then jump, 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 jump.